quiz we did one quiz that I counted for 5, right? And then the homework we did so far, the sets that were closed, I counted them for 4%. So what you got today is a snapshot of your grade, right, as of today. Okay, and it is only on 24% of the whole grade. This is about the quarter. Okay, so quarter is not like, we still have like 76% outstanding, right? Which means everything can happen. You see, somebody be failing right now and they can end up with an A or B, you see? So, and vice versa. Somebody be passing right now and they end up failing. So what you see here, when I look at the grades, yes, go ahead. You raise your hand.
So Dr. A, Professor A, so when the problem that I'm having with the math part of the homework is I'm putting the correct answer in, but I'm not getting it correct.
The right format.
Yeah.
Look, so look, for instance, okay, having the right answer and be counted wrong from my open math happens time to time, but I can assure you it's not very often, because
how about I send you a screenshot of it, because I saved a screenshot.
yeah, okay. So you can send me screenshot, and then for illustration to everybody, I can go right now. For instance, you give me an example of problems right now, and we can share with everybody. I go there and see the input, right?
Perfect.
And, okay, so for instance, what problem can, for instance, one example of problem you're referring to?
Can I log in? Because I have it on my. I'm gonna
log in.
I
can show. For instance, I can show your. So what section was it about?
It's the new section, actually. What we just started.
Okay. That you see, that is scientific notation. I understand that. So now, what happens for scientific notation? You see, I'm looking at it here. So let me share the screen to everybody. I hope you don't mind if I share your screen. I mean, if I share your work.
No, please. Okay. Someone else could learn from my mistakes too.
Yeah, I mean, this one, I was expecting somehow, right? This one here, because my open math, unfortunately, does not understand sometimes. So you see my screen, right? My open math, how my open math reads this?
Oh, there you go. Now we see it. Oh, yeah, that's the one.
How my open math reads this? It reads it as X. Right. It does not read it as a multiplication. Okay? So when you do this right now, when you do the box right now, I think either it's going to show you the multiplication. If it doesn't show you the multiplication, you put times, you see? Because unfortunately, my open math, does not understand this as a multiplication, Let's try this. Multiply by, right?
Yeah, mine was doing that too.
Okay, so which symbol would you pick? Because, go ahead.
Multiplication times, right here. Let's try this. Shift 8, let's just star.
Okay.
Let's try the star. If you try the star here, you're gonna see is right, but then if my open math, normally it should give you I'm sorry, it should give you the, right here, you see the star right here?
Yeah.
Yeah. You see, right, the star, not X. The star right here. Shift 8. When you write Shift 8, now if you submit that, it's going to give you the right answer. I mean, these are examples of shortcoming of the technology, okay? Because when you write X, actually, all of us understand it is a multiplication, right? But this is a computer, okay? So, sometimes you have to look at the hints here. You see here, more. When you write more, you say enter your answer in scientific notation example. Why they give an example even? Because they know some people will write X. Okay, that is why they give you this example. Right? You see what you wrote here is a star, right?
Yeah.
Yes, a star. Okay. I'm sorry for this example. I'm sorry for that.
No, it's not your fault.
Yeah, because this one, okay, this one I know it's happened. You see here, now you have this one is right answer. You have the multiplication, etc., etc. All right, exactly. So okay. So I was saying one of the examples about one of the lessons we can get from the progress grade is that in 082, it is very frustrating if you get a 67, you get an F. That is very frustrating. I understand that. You have to avoid to be in that spot, right? I rather fail with a 50, right, than with a 69. If I fail with a 69, I'm going to be sick, right? And in 082, we don't have a D. We don't have D grade. It's from C to F. Okay? If somebody has a 67, 68, 69, they still get F. So what's going to make the difference sometimes? What's going to make the difference sometimes is a homework. Because the test is a test, you know, you can do one test, one bite, etc., but the homework is up to you. You can go ahead, and the sets are open for a long, long time. You can go ahead and score 100% on all of them. I have some students who score almost 100%. So everybody in this room can do that, okay? And if you want help with a particular problem, you know, I always answer to some students who send me, who ask me questions. I do answer to them. All right. Okay. So we're gonna do the quiz will be open right after class, right? We're gonna open the quiz. We're gonna talk about it after. Okay. So now let's go ahead and continue the scientific notation. You know, we are almost at the end of it. So we're just gonna do, but first let me share my screen again. All right, okay, so I just wanted to say, this morning with my other virtual classes, the team session was cut off like maybe 2 or 3 times. Okay, I hope it will not happen to us. But if you don't see me in the meeting, don't log out. Just wait for me. I will try. You know, is the internet, is the CCBC internet? That is not right. Okay. So at Owings Mills. So hopefully it will not happen to us. All right. So let's say, for instance, you want to write in the scientific notation. First of all, what do you think? If I have 367 times 10 to 8 power, right? You see, this number as you see it, is this number in scientific notation?
No.
No.
And what would be the reason for that? Why it is not? Because?
Because it has a root notation.
Why it is not in scientific? You see, every time we say yes or no, we have to have the justification, just nearby. Why it is not? I agree with you. It is not in scientific notation. What fails it to be in scientific notation?
It's not between the numbers of 1 and 10.
Thank you very much. The 367, the mantissa, 367 is not between 1 and 10, right? So you have to make it between 1 and 10. Every time you have a number, what we call the mantissa is the number right here in front of the power of 10. That number, if that number is not between 1 and 10, then it is not in scientific notation yet, right? So we have to make it be in scientific notation. So this is 0.00, right? So we have to move, how many spots we have to move it to the left side to get a number in scientific notation?
2.
Two spots. Well, since we moved it to the left side, did we make it bigger or did we make it smaller?
Bigger.
Smaller.
I mean, the original was 367. So now we end up with 3.67. So we made it, of course, we made it smaller, right?
Yes.
You have to compensate that. When you make somebody smaller, you have to multiply by a positive exponent of 10, right? To compensate the fact you made it smaller, right? So this one is 3.67. I moved it 2 spots to the left. I have to multiply by 10 to the second power to compensate the 2 spots to the left I moved, right? Okay, that is just the 367. I don't forget my 10 to the 8 power, right? I don't forget that one, you see? Everybody see that?
Yes.
Yes.
Now we have to group these two right here. When you group them, what you do to the exponent, we add them up or we subtract?
Add.
We add them up. It's going to be 3.67 times 10 to 10 power, right? And now we have a scientific notation. Okay? So in the same way, if you have this multiplication right here, 2.18 times 10 to 7 power multiplied by 9.68 times 10 to negative 4 power. We are asked to write this number in scientific notation. It is a product, it's just a regular product, okay? The numbers are not nice, but they are not intended to be. They are not intended to be nice, okay? You see? So in no way I can do 2.18 times 9.68 monthly, right? I have to use a calculator.
Right.
See that? So what you're going to do here, if you're going to use a calculator, we're going to do this, multiply this two right here, right? Remember, this is just a multiplication. When you have, if you have all multiplications, you don't distribute, right? You agree with that? You don't distribute. You distribute a multiplication to additions or subtraction, right? But if everything is a multiplication, you don't multiply somebody by somebody else twice. You don't use a number twice. You just use everybody once. For instance, you all know if you have to do 2 times 4 times 3 times 5, every number you use here, you're going to use it only one time, right? You agree with that? You don't distribute, okay? You know, if you prefer, you can do 2 times 5 if you wish, right? Because 2 times 5 will give a nice number, right? See, 2 times 5. But then when you do 2 times 5, you are done with them. Now you are done with them. 2 times 5 is 10. Now you don't reuse them anymore. And then 10 times 3 is 30. You don't use 3 anymore. 30 times 4 is 120, and then you are done, right? So here, we are free to multiply this number by 9.68. We are free to do that, okay? But we're going to just do it once, right? And then I have to use my calculator, okay? So you can use your calculator at the same time with me, you know, if you have a calculator. So this is 2.18 times 9.68.
24.
Which is 21.1024, right?
Yes.
21.1024. Now, it is very natural for me to group the exponents, the powers of 10, right? That is just natural way to do that. So it's going to be 10 to what power?
The third.
10 to the
Thank you
third.
very much. 10 to the third, because we do 7 plus negative 4, right? 10 to the third. You see, we would be done if the number in red was between 1 and 10. Unfortunately, that number in red is not between 1 and 10. So what you have to do?
So you have to carry the decimal to the left one time.
Yep. Thank you very much. So we have to do exactly what we did before. We have to carry the decimal point to the left one time, right here. And since we made it smaller one time, how many powers of 10 we have to multiply? How many positive powers of 10 we have to multiply?
4.
1.
1 positive power of 10, because we moved it one spot, right?
Right.
It's going to be 2.11024, right? And then multiply by 10 to 1 power. You see, this 1 power is to compensate the left move, right? That one power over there is to compensate the left move. What I don't forget, I don't forget my
10 to the third. So would you?
exactly 10 to the third.
So you would subtract the 1 and the 3.
You would subtract or you would add?
Oh no, you would add because you're in a positive number.
Because you are multiplying, right? Right. When you multiply, you add, right?
But what makes it different from the second one with the 2.18 times 7 or the 10 to the 7th power times 9.68 to 10 to the negative power? So we subtracted there because of the negative.
No, we add it. We add it, but since one of them is positive, one of them is negative, it's going to make it smaller.
I got
like
it.
But
Gotcha.
we added actually. You see, I wrote it to the right side.
The powers are always going to be an addition.
When you multiply them, when you divide, you subtract, right?
Okay.
When you divide, you subtract. When you multiply, you add the powers.
Okay.
Okay. All right. So that is, that is the stuff we're gonna practice right now. I'm gonna give you a couple of them, right? So do this. Right, that's the first one. And then the second one.
Is this 3.3?
Yeah, scientific notation. Let me double check the section.
Okay.
Scientific notation is yeah, it's 3.3.
Okay, thank you.
Mm-hmm. All right. So this is very likely a calculated job, right?
Yes.
At least the first ones, So okay, so you're gonna multiply. Can somebody tell me what they did?
I can.
Go ahead, please.
So I multiplied 7.05 times 8.16.
Uh-huh.
I got 57.528.
Yep, 57.528. Okay, and then what you did next with the
I
10?
got 10 to the negative 2. Because
How you got negative 2?
I added the -5 and the 3, which gave me -2.
Thank you very much. That is absolutely correct. So now, do you have what you want, or do you have to do something extra, something
No,
more?
I had to go further with it. So I moved the decimal to the
Uh-huh.
left once. So
Yep, everybody see that to the left ones, right? So you get
5.7528 times 10 to the first power.
Why 10 to the first power?
Because I moved one. I only moved one decimal to the left.
Exactly. I agree with you. So
And then I had 10 times 10 to the -2. And then my final answer was 5.7528 times 10 to the -1.
Thank you. You see, that is absolutely correct. Okay. All right. How about the second one, somebody else? What you did is the second one. $1.347 times
2.15.
How much you got?
2.89605. And then I did it times 10 to the 16th power.
15 power. Thank you. So now, are you done, or do you need to do something more?
Hey, wait a minute.
I'm
Before we go
done.
any further, I got 2.881. I'm just wondering how she got 2.890.
605. I think it's a matter of, you know, what numbers you what are the numbers you put in your calculator to get the answer. I think I got the same answer myself. When you multiply 1.347 by 2.15, you get 2.89605, right? Okay, when you multiply this one as you see it by this one as you see it, you should get 2.89605. Okay.
You know what? I didn't do the 7. That's why. Okay. I see
Okay.
where the mistake is.
Yep.
Yeah,
So,
and then I did it times 10 to the 15th, but I'm finished, I think, because I'm in between 1 and 10.
Thank you very much.
Okay.
You are absolutely correct, because the 2.89 is a good number. It is between you know 1 and 10. So that is a good number. So you don't have to continue any further. Okay, so now let's do a division. You know, some type of division. For instance, we say right. For instance, we say you know, I just make up numbers myself. You know, 25.13 times 10 to 8 power divided by, you know, 7.65 times 10 to -3. First of all, here we are dividing, right? Since we are dividing, what you're going to do to the exponents? Do we add them or do we subtract them? Subtract them. Exactly. Thank you very much, everybody. So I know then, since we subtract them, we will have times 10 to what power then?
To the 5th power.
To the 5th power. Now we have to watch out the mistakes. Now, remember, we are subtracting. So when you subtract, you do 8 minus what?
-3.
What happened to the 2 minuses?
It'll be added.
They will be added. So you're going to be 10 to what power then?
11.
11. Thank you. So now, this number now, right here, this number, you're going to just divide them. If you divide 25.13 by 7.65, if you get a good number, then you are done. If you don't get a good number, then you do one extra step, right? And here, of course, you have to use a calculator, right? So it's going to be 25.13 divided by 7.65. That is 3.28. I mean, we're going to round, okay? Let's round a little bit. So 2.285. I round it, okay? 3.285.
Oh, okay.
3.285. Is that a good number?
Yes.
It is a good number, right?
Yeah.
So
Yeah.
since it is a good number, so I'm done. Okay, one last example, and then we're gonna move on to the next section. So all right. The numerator, in the numerator, we have 1.17. In the denominator, we have 18.3. All right, try to do this one. All right. Something a little bit will change right here. Can somebody tell me what is going to change that compared to other examples? For instance,
Would we have to go 2 decimals to the right this time instead of to the left to get it to a number
exactly,
1 and 10?
exactly. Thank you very much. This is, this is what's going to change for this example right there. So, but first, tell me what's going to be the power of 10 here? 10 to what power?
-10.
-10. Thank you. It comes from -4 minus 6, which is -10. Now, exactly, you were right here. When you divide 1.17, when you divide 1.17 by, by 18.3, so we get 0.0639, right? 0.0639, if I round, okay? So here you were exactly right. Now here we have to go to the right side. 2 spots. When you go to the right side 2 spot, are we making the number bigger or smaller?
Bigger.
We are making it bigger 100 times. Since we are making it bigger, we have to compensate that by multiplying by a negative exponent, okay? When you make the number bigger, you have to compensate by multiplying by a negative exponent. When you make the number smaller, you have to compensate by multiplying by a positive exponent. So here is 6.39 times 10 to, how many spots we went to the right?
2.
So we multiply by -2, you see, to compensate that, and then times 10 to the -10, which was here in the first place, right? So my final answer will be 6.39 times 10 to negative, how much?
Is it -12?
Thank you, -12.
I have a question.
Yeah, go ahead.
So how did you get 10 to the negative 10th power.
Okay, so the rule is when you divide exponents, you have to subtract them, right?
Yeah.
Now you can elect to subtract two ways. You can subtract the exponent on the top minus the exponent of at the bottom. Then you have to do the answer where the negative 4 is, right? Or you can subtract the one minus one at the top. You have to do the answer where the 6 is. Okay, but here this is a scientific notation. We want everybody to be at the top, right? So when you do -4 minus 6, what you get? You see, -4 minus 6, you get what? Negative. If you don't get -2, you get -10, right?
Right.
Okay. I mean, you can because this is like adding two negative numbers. Okay. -4 minus 6 is like -4 plus -6. Okay.
Okay.
And you can use a calculator. Yeah, and you're gonna type your calculator as you see it. -4 minus 6.
Yeah, at first I did -4 plus 6.
No, it's -6. Yeah.
Yeah. Okay.
All right.
Thank you.
You're welcome. All right, so this is, the section about scientific notation, okay? After that, we're gonna see the section about introduction to polynomials. So what is a polynomial, etc., right? So, and this is 3.4, okay? That is 3.4. Introduction to polynomials. Okay, so a polynomial, as you can see, poly. So polynomials is something, an expression that is made up by some type of terms, right? We put some terms together, not any terms, some terms together to get a polynomial. What type of terms are you talking about? You see? So, for instance, polynomial is made up of terms. Right? Terms like what? What type of term? When you have a number, like for instance 6, multiplied by some power of the variable. Numbers, terms like that. You see, that is a term that you can see in any polynomial, right? Here, this is a coefficient, real number. And this is an exponent that is a positive integer, an integer greater than or equal to 0, right? Any term that look like this, a number multiplied by some power of variable can be a constituent of the polynomial, right? The power over there, that power cannot be negative, okay? If the power is negative, then that term cannot be inside a polynomial. If the power is a decimal number, like 1/2 or 1/3, that term cannot be inside a polynomial, okay? The exponent has to be a positive integer. An integer just is greater than or equal to 0. For instance, all these terms, you see, I give an example of this. For instance, all these terms right here, -2x, right? 7, right? 5x squared, right? 10x to the 4th power, etc., etc. All these are called monomials.
Monomials.
Yes. because they are one-term polynomials, right? They are polynomials where we have only one term. They are called monomials, okay? And look at all the exponents. Look at all the exponents. All the exponents must be positive or 0. You see here, what is the exponent of 1 in the first one? Negative 2x. What's the exponent of x?
Negative 1.
It
Sorry.
is 1, right? We just don't need to write 1, but it's 1 right there. The 7, I even don't see no x, but if I choose to write x in it, what exponent I should put here at the top of the x?
1.
If I put 1, it's going to be 7x. But if I want x not to count, what
Oh,
exponent?
you want it to be 8, right?
No. If I want x not to count, what? 0. Thank you very much. You see, what is x? What is any number to 0 power? Is 1, right? Okay. Any number to 0 power is 1. So all these right here are polynomials. So what is, are monomials. What is a polynomial? Is a collection of monomials, right? So for instance, we say, and then after monomial, we have, when you say 7x plus 5, right? When you say x cubed minus 1, when we say 5x squared plus 3x, all of them here are binomials, right? Because how many terms I see in them? How many monomials? For each one of them. I see 2 monomials. So we call them binomial, right? So, and something like that, you know, x squared plus 3x minus 2, this one you have 3 of them, we can call it a trinomial, right? So now, in general, all of them are polynomials, right? You know, all of them are polynomials. When I say, you know, 8x to the 4th minus 3x cubed plus 2x minus 5, this is a polynomial, right? So what we have to retain for us in 082, we don't need to dig deep into the definition of a polynomial. We just try to retain that it is constituted of terms that are a number times some power of the variable. And that power, that exponent, should be a positive integer. That exponent should be a positive number. It cannot be a decimal. It cannot be negative, right? That's what we understand by polynomial. Now, in mathematics, of course, we have a great deal of polynomials. We use them a lot, right? If you do math, okay? So, but here in 083, 082, we just learn what is a polynomial, and then, you know, we try to evaluate the polynomial, you know, etc., etc. So, evaluate polynomial. Evaluate.
That says 2x minus 3 or 5. 2x
Where's
minus
that?
Okay, no, I got it.
Yeah, okay, 2x minus 5, I'm sorry.
Yeah,
Evaluate. Evaluating polynomials, right? So when you say, for instance, the polynomial, evaluate the polynomial x squared minus 5x plus 7 when x is equal to 3. If I ask you to evaluate this polynomial when x is equal to 3, what you gonna do?
You're gonna put the 3 where the x is?
Exactly. You're gonna put the 3 where everywhere you see x, right?
Mm-hmm.
You see, it's gonna be, so you're gonna evaluate, you're gonna put 3 everywhere. So you put 3 here and then square, right? Minus 5 times 3, right? And then plus 7, and then you do the math, okay? But you're gonna substitute the 3 everywhere you see x. So you're gonna be 9 minus 15 plus 7, which is 1, right? Okay. And then when you evaluate, you try to respect the order of operations, right? Okay, so, and then here, this one right here, x squared minus 6x plus 3 when x is equal to -2. Now here now, you're gonna substitute x with -2, right?
Uh-huh.
Okay. Unfortunately, everybody try write by yourself on your paper how you're gonna substitute the first one, the x squared. Okay, I think everybody doing it, right? Substitute the first one before we do it, and then you're gonna compare what you're gonna do with what you wrote. Substitute the x with -2 everywhere. Everybody's done substituting. I'm not asking you to do the calculations yet, just a substitution. Okay. How many of you wrote -2 squared like this? How many?
Me.
Me.
Okay. You see, that is very, very, very expected. That is very, very expected.
Then stop tricking us.
I mean, look, it's very, very expected because there is something in math that plays a very, very important role. But unfortunately, sometimes we forget about it. What I want to talk about here.
Is it a negative and a negative make a positive?
It's going to make a positive, but until you put what around the -2.
Oh, parentheses.
Exactly. There is something in math that plays a very important role, and sometimes we just dismiss it as the parentheses. Okay, the parentheses are really, really important. So what you're going to do, you're going to put parentheses around the -2. Why did you put parentheses around 3? Why we didn't need to do that? If you do, it's not wrong if you do. But why we didn't need to do that? Because
it's a negative number.
Exactly. 3 is a positive number, -2 is a negative number.
Oh, so when it's a negative number, we gotta put parentheses around it.
Exactly. That is exactly right. When it is a negative number, every time you have exponents involved, put parentheses around that number. Every time.
Okay.
If I can show my here, I hope my calculator will not let me down. If because now the calculator, the calculators now they let you down from what you wanna. Okay, so look, if I do this right here, everybody can see my calculator. Hold on.
No, not yet.
This is my calculator, right? Okay.
No, we don't.
Let's try -2 squared without the parentheses, right?
Mm-hmm.
Let's do -2, and then let's square that. You see my calculator. You see what my calculator did. This I was talking about. It let me down. You see what they did?
Oh, it turned it into a positive numbers because of the two negatives.
Because my calculator corrected that. Look at here. Look at what you wrote. Look at what calculator did. SQR of what? Parentheses -2.
Huh.
You see, my calculator calculates the square of -2, right? So what I want is, I don't want to do that. So I want to do this. I want to do, because when you do -2 square without the parentheses, right here, when you do this -2 square without the parentheses, who is squared actually? Who is squared?
-2.
You see,
+2?
I don't see -2 squared. I see 2, which is squared. The negative here is not involved into the squaring here. Do you get that? Remember last week?
Yes.
Remember last week when you write this, when you write xy to the 5th power, who is raised to the 5th power?
Why?
The y.
Is x raised to the 5th power?
No.
No.
Yeah.
Okay.
Yeah.
No, we raised
No,
to
x is not. X is not here. What is the power of x actually?
1.
1.
It's 1, right?
Huh?
until you do that, until you do this now. Now, who is raised to the 5 power now?
That makes sense. Okay.
Now, both of them are big. So don't view -2 as a single number. -2 is a composition of two numbers. It's -1 times what? -2 is -1 times?
1.
No, -2 is -1 times 2, isn't it?
Yeah.
You see, that is -2. It's -1 times 2. So when you do square right here, who is squared now?
The 2.
2.
Only the 2. When you do this now, who are squared now?
The 1 and 2. Both.
Yeah.
Both of them are squared, right? So the bottom line is, you see my calculator, this calculator is a new calculator. So it basically is corrects what you want to write. When you say -2 square, is take it as a -2 whole square, right? But in the other calculators, like the TI-80, TI-8284, etc., those calculators they write exactly what you write in it. They get you exactly what you write in it. Okay. So the thing is, do not forget when you raise a number, when you raise square to a power, please don't forget the parentheses, right? Okay, that was my point here. And then of course everybody gonna do -6 times -2 here, right? And then +3. Okay, and then we do the math. Now, how much is -2 all squared? Positive what?
Positive
4.
8.
-2 all squared is positive 4. It's -2 times -2, right?
Mm-hmm.
Which is positive 4. So now +12 and then +3, which is 19. That 19? All right, so now let's see this example right here, and let me see how you're gonna do it. So -x² plus 5x minus 1, when x is, of course, how you gonna do this?
Turn them into a positive.
Yeah, it's a substitution. First, everybody try to substitute, and then we're gonna see if the way you did it is the right way or not. Try to substitute, everybody. All right. So right here, tell me how you substituted. Somebody tell me what you did, the first substitution, which is the key. You have a negative x squared, right? You see, this negative is a negative x squared right here. Okay. How are you going to do it? Do we change this negative right here?
No.
All what you do is to replace x with -3. So this negative is left as is. Now this x now, we can substitute it with -3. But remember what he said? You have to put parentheses around it, right?
Right.
Plus 5 times -3 minus 1. So -3 all squared is what? Is 9, right? But then this negative is right here. This negative did not go anywhere, right? Minus 15 and then minus 1. If you have a calculator, if you have scientific calculator, you can write exactly what you see, right? On your scientific, because your scientific calculators, they accept parentheses, okay? But it's very important to input, what you want to input, right? For if you have that. So it's going to be -25. All right. So I think what you're going to do here is we're going to take an early break before we go into the next stuff. The next stuff you're going to do is we're going to see how to add polynomials and how to multiply polynomials, right? How to add them, how to subtract them, and how to multiply them. You're going to see it's not like very, very, very hard, right? So we're going to take a break, everybody. So about 10 minutes break, right? And then we're going to come back.
Wow, I never knew.
All right, so I think we are back. So okay, so we're gonna see now how to add, how to subtract, and how to multiply, polynomials. Okay, we're gonna see that. So basically, adding or subtraction polynomials is, you don't overdo it. We just apply the algebra rule that says combine like terms, right? It's add, addition, subtraction of polynomials. The rule says in algebra, the general rule of algebra is combine like terms. Like terms. Now, what do we call like terms? The like term is same variable, same exponent. That is like term. Same variable, same exponent. This is a like terms, right? If the variables are the same, but the exponents are not the same, not like terms. If the exponents are the same, but the variables are not the same, not like terms. The like terms here, for instance, we say 18x cubed and 9x cubed, are they like terms?
Yes.
Yes, these are like terms. When we say 3x and negative 7x, are they like terms?
No.
Look at the variable. Do you see the same variable?
So they are like terms because the variable is the same, which is x, right?
Yes, and the exponent is also the same, which is what?
1. Okay.
Which is 1. They are like terms also. When we say 9 and 17, are they like terms?
Wait,
Yes.
Yes, they are like terms because
they
both of them are numbers, right?
the 3x and the negative 7x, why are they like terms?
Because we have the same variable xx and we have the same power 1, 1.
Okay.
We just don't need to write the 1, right? Okay, you see, in each case here, we have like terms. Now I give you examples of some stuff that I don't like terms. When I say 5x cubed and 5x squared, are they like terms?
No.
Why?
Because the exponent is different.
Exactly. These are not like terms.
So the exponent has to be the same, correct?
Exactly. We even almost don't care about the number in front, right? It's only the exponent and the variable. If I say 7x cubed and 7y cubed, are they like terms?
No.
Yes. Oh no, because their variables is different.
Yes, the variables are different, so not like terms. Okay.
Okay.
So now, an algebra rules tells you when you have like terms, you can go ahead and group them. It's like saying, for instance, you say when you want to add or subtract, you say, for instance, 8x squared plus 7x squared, right? Before you group them, you make sure they are like terms, right? If they are like terms, they can merge into one term. If they are not like terms, they will not be able to merge to one term.
So would you still add the exponents?
We just don't add the exponent. I was coming to that. Thank you very
sorry.
much. You see here, that is very important remark, right? Because unfortunately, some of us do that mistake. So when they are like terms, we can add them up. But when you add up, we just add the numbers up front. Okay? It's going to be 15, and the 15 come from 8 plus 7, right? 15 what? X squared. You don't put x to the fourth, right?
Oh,
Okay. So
It's like saying 8 cars plus 7 cars. How many cars?
15.
15 cars, right? Do you say 15 cars squared? Or do you change the power of car? You don't change the power of car. You just say 15 cars, right? Same thing here. It's like 8 apples plus 7 apples is 15 apples, right? So there's no change here. If they are like terms, just add these two numbers is 15, and then you just put the common term, right? Do not change the exponent. Do not change the exponent, right? So it's like when you say 10x minus or plus, 8x. Are they like terms?
Yes.
Yes.
They are like terms. Since they are like terms, we can go ahead and combine them, right?
Yep, it'd be
How much is it going to be?
18x.
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 18x. And do I go ahead and change the power of x?
No.
No, we don't change the power of x. It's 10x plus 8x is 18x, right?
Okay.
It does not become 18x squared. Don't change it, okay? Addition or subtraction, when you say 9x to the 5th minus 11x to the 5th, addition or subtraction do not change. They don't change the power. Addition or subtraction of terms do not change the power. So we don't have to conflate that with when you multiply, right? When you multiply, the power changes, of course. But when you add or you subtract, the power does not change, right? Okay, so here, are there like terms here?
Yes.
So what's going to be my answer then if they are like terms?
2x over 5.
Negative 2x
Negative 2x to the
fifth power.
fifth power, right?
Oh,
You see
right.
that? Exactly. It's like, you know, I just go ahead and group the numbers. Okay, so you see, that is the general principle of algebra. Combine like terms. The only terms we can combine and we can merge together are like terms. If they are not like terms, we will never be able to merge them together, right? Okay, so let me put here some of them here. You see? Sorry about that. All right. I have two good examples here. One is addition, the other one is subtraction. Now tell me, why the second one is little bit trickier than the first one? Why?
Because they have different exponents.
They have different exponents, right? But there is some major thing. That means the second example is little bit, we can, you know, it's a little bit more prone to mistake than the first one. What is that major, you know, difference?
Oh, you have adding and subtraction?
Yes, there is a minus in front. You see, there is a minus in front of the second parenthesis. That minus, we have to take care of that, right?
Okay.
You see, before you go ahead and group the like terms, you're gonna distribute the minus sign inside, right? And when you distribute the minus sign inside, what's gonna be the effect of it?
And turn it into a positive?
It's gonna change any negative number to positive number, any positive to negative, right? This is what happens when you distribute minus to a parenthesis, right? You see the first one here, we can just go ahead and remove the parentheses. They don't play no role here, okay? Because in between you have a plus, okay? The first example, in between the parentheses, they play no role, absolutely no role at all, right? Because in between we have a plus. The second one, the second example, the parentheses, at least the second parentheses, the second set of parentheses, this one, play a big role here. Before we do anything, you have to distribute the minus sign inside. Okay? So let's do it together. This example, and then I give you other one to do by yourself. Okay, the first one here, because of the plus here, the second parentheses, the parentheses do not play a major role. Which means we can go ahead and just go ahead and dismiss them. They are not important here, right? Because we don't have a multiplication. There is no multiplication. There is nothing to distribute, right? Okay, so right here, we're gonna go ahead and apply the algebra rule. We're gonna group, look right here. So I have plenty of colors, so I know who to group. We're gonna group the first one with what? 4x cubed with what?
7x cubed.
Exactly. These two together is going to be 7x cubed. And then I have another color. I use the blue one. The 2x. Do I have somebody to group 2x with on the other side? I mean, on the other part?
No.
No.
I don't see nobody to group 2x with, right? The 8. Can I group the 8 with somebody?
The 11.
Yes.
The 8 and the 11, negative 11. So it's 8 minus 11, which is how much?
Negative 3.
Negative 3. And then the 9x squared is, of course, by itself, right? Because we don't have another 9x squared. It's just 9x squared. Now look at this right here. Is that organized?
No.
No.
It's not organized. You know, the exponents are all over the place. So just for aesthetics, right? Nothing more, just for aesthetics. When you have your polynomial, you can choose to order them in the decreasing way of the exponent or the increasing way of the exponent. You can choose to do that, right? But if I leave it like this, does it make my answer wrong? Not at all. My answer is right, okay? But it's not nice. It's not jolly, right? So what you say? So we're gonna order them 7x cubed. We're gonna choose the decreasing way. We're gonna put the highest exponent to the lowest exponent. Minus 9x squared minus 2x minus 3, right? Okay. And that here does not change the mathematical value of the other step. It doesn't change the math value. It's the same thing. We just order them, okay? Okay, this one right here, like I said here, because of the minus, at first here, because of the minus, you have to distribute the minus to the second parenthesis.
Oh, to the second, okay.
The minus sign to the second parenthesis. Everybody see that? We don't do anything until we do that, until we distribute. Remember, the minus is like minus 1, okay? We just don't need to write the 1, but picture that you have negative 1 there. It's going to be 5x squared minus 2x plus 7. You see, these two, I can remove them because there is nobody here. There's nobody here, so I can remove the first parenthesis. Now, the second one now, I'm going to distribute them. Okay, when you distribute the negative sign, it's going to change any plus to minus, any minus to plus. What's going to be the first one then? Minus what?
3x squared.
Then
Cubed.
what next?
Minus 6x.
Thank you very much. It changes this plus to minus.
4.
And then what next?
Plus 4.
Plus 4. Thank you. It changes this minus. You see the two minuses make up a 2a plus, right? Everybody agree with that? Now I go ahead and group the like terms. Okay. Since we know sooner or later we'll have to order them. What is the highest power here?
3x cubed.
So we're gonna write that one first, right? We're gonna group the highest powers first, right? And then the next one, and then the next one, okay? Because I know sooner or later I will have to do that, okay? I mean, it's not obligation, but it's nicer. So which term we gonna write first then? If you want to write from the lowest,
3x cubed.
Negative 3x cubed, right? And this one is alone. We don't have another one. What is the next power we have to consider?
Plus 5x squared.
Plus 5x squared. Do you have a like term to 5x squared?
No.
We don't have a like term to 5x squared. It's going to be plus 5x squared. And now we're going to choose the x's, right?
Mm-hmm.
And now we have two x's. We have this one, and we have this one. What happens when we group them? How many x's we get?
Negative 8.
8x squared.
Thank you very much. Negative 8x. The power, does it change? Again? The power does not change. When you add, the power does not change, right? And then the numbers, what are the numbers? 7 and
11.
plus 11.
Plus 11.
Okay, so this is how we combine, polynomials. Again, we follow the algebra rule that says combine like terms, right? This is what we did, combine like terms, okay? So
when I
go
wrote
ahead.
mine didn't, like where your green is, mine didn't quite look like that, but I did get that answer.
Okay, you get that answer. So in your answer, do you feature every term you will see here in my answer?
Okay.
Does your answer feature any term that you see here in my green one?
Yeah. Yes.
Okay, so your answer is good. You see,
Yeah,
if they match.
I just didn't have the like where your green is, the negative x. Negative 3x to the third power. I didn't have all that. I just put it like 5x, negative 2 x plus 7 minus 3 to the third and all that. So, I mean, it just came out right. I just didn't, my steps just aren't like yours.
No, I think the point you want to make is you don't have the same order.
Yes.
If you don't have the same order, the order doesn't matter almost, right? But if you have another term that doesn't match here, one of them here, then we have two different answers.
Okay.
And if you have two different answers, one of us, has made a mistake, right? In math, we always we just have one answer in math, right? Unfortunately.
Okay.
So, but if the order doesn't match, that is okay. The order is, for instance, in the test, I will not, whether you have, very well ordered or not ordered, I give you the grade.
Okay.
If your answer is good.
Okay.
Yeah, absolutely. So, right here, so, I mean, I even know like this example from the book. Let me make up my own examples. Okay, so add or subtract. So we're going to do.
Hmm.
Plus that's the first example right there, right? And then the next one. Okay, let me write a little bit, give it some space so we can go ahead and. Okay, the next one. Then minus. All right, so you have two examples, one with a plus, one with a minus, and then you're gonna see what you're gonna get, right? All right. Okay, so can somebody tell us what they did with the first one? So, and let me ask the question. In the first one, the parentheses, do they really matter here?
No.
No.
Oh,
You know, they don't. Because, you know, in front, a parenthesis does matter when you have something in front of it. If you don't have nothing in front of it, then the parenthesis does not matter. You see, the black parenthesis, you have nothing in front of it. The red parentheses, we have nothing in front of it except plus. So plus doesn't change anything. So it's like they don't matter. So I can go ahead and group the like terms. The 9x to the fourth, does it have another like term?
Yes.
Yeah.
Which is what?
2x to the 4th.
Okay, so when you group them, how much you get?
11 x to the
11
4th.
x to the 4.
11x to the fourth. And please, again, don't change the exponent, right? The x cubed, does it have any like terms?
No.
It does not. So it's going to be by itself, right?
Mm-hmm.
The x squared, does it have any like term?
Yes.
Yes.
Which is?
Negative 4x squared.
Like that, right? So when you add them up, how much you get?
Negative 3x.
Negative 3x.
Negative 3x squared, right? That is correct. And then here, the 5x, of course, the negative 3x and the negative 5x are like terms, right?
Mm-hmm.
Yeah.
When you add them up, you get how much?
Negative 8.
X.
Negative 8x. Thank you. And then the numbers, they are like terms. When you add them up, you get?
Negative 7.
Negative 7, right? That's it. And we said here, these parentheses here is like they don't matter. Now, for the second example, do the parentheses matter?
Mm-hmm.
Yes.
They do. So what we're going to do here, we're going to take our time and distribute the negative sign, right?
Mm-hmm.
Okay, what you get? Tell me.
I wasn't done that one quite.
Negative what?
8x.
So we're not doing the calculation yet. We're just going to distribute the negative sign.
Yeah, so I got negative 8x to the 3rd. Minus x squared.
Yep, the plus become minus, right? And then?
Minus 2x plus 13.
Minus 2x, same thing. The plus become a minus. And the last one?
Plus 13.
Thank you.
Yeah.
Now we go ahead and group the like terms. The x
Mm-hmm.
cubed, the first x cubed, is it like term with somebody?
Yeah.
Yes.
It is, right? These two together, how much they do when you group them?
Negative 18.
18.
X to the third. X to the cube, right? And then these two, the x squared and the x squared, are they like terms?
Yeah.
Yes.
What happened to them?
They cancel out.
Do they cancel out? You see, I asked the question that trick you.
It would be negative 2x.
Because they are the same, so they don't cancel out because they are exactly the same. They add up. You see, we have negative 1 in front here. We have negative 1 in front, right?
Yeah.
So it's going to be negative 2. Negative 2x squared. Okay? Now comes the one that cancel out, which is 2x and negative 2x. How much you get?
Plus 4.
That is, no, it's 2x minus 2x is how much?
Oh.
They cancel out. You see, these two cancel out, right? And then negative 9 plus 13 is positive 4.
Right. Okay.
All right?
Yeah.
Yeah. So that is, so now here, I'm going to just give one last example and then we move on to the next topic.
Can you move back down so I can finish right there? You go.
Yeah, I'm sorry.
That's okay.
So we're gonna do the last one here.
Thank you.
Okay, so we have, this one is longer, but no panic, it's the same. So, do you see, this is what I was talking about, right? I was talking about that the internet get cut off right here at Owings Mills. It just happened now, you know. It didn't happen, you know, a lot today. I mean, a lot this time. Because in my morning class, it happened to me like 3 times, 4 times. Okay, so we have this one. I let you like some good 5 minutes. Everybody try to do that. And then we're going to compare our answers. All right, so I think it's been 5 minutes, so we can go ahead and try to go over that example. So at first, we're going to remove all the parentheses, right? Tell me what you got. If you remove all the parentheses, somebody tell me. You have what?
You will get 6x minus 5x to the 4th.
Yep, and then
minus 4x squared.
You see, nothing changes from the for the first parenthesis because there is nothing here. Nothing is here, right? Okay, now the second parenthesis. Now what's gonna happen?
It would be negative 2x plus 7x squared.
That is right. You know, the minus 7 changed to plus 7, right? And then plus?
Plus 4x to the 4th.
That is right. And then
plus 8.
Plus 8. Thank you very much. You see, I change all signs. Everywhere I see plus, I change to minus. Everywhere I see minus, I change to plus. The last one now, what you get?
6x, negative 2x.
The last one here, the last parenthesis.
I
mean, you see, that's very good now. When you say 8 minus 6x squared, the 8 and the 6, they don't go together.
Right.
Yeah, we cannot say 8 minus 6, right?
Negative 8.
So 6x squared.
Yeah, it's going to be negative 8, right? And then plus what?
Plus 6x squared.
Plus 6x squared, and then plus?
Plus 4x to the 4th.
Exactly, right? Okay, so now we are ready now to group all the like terms. No, we just for the sake of being organized, we're gonna go from the highest exponent to the lowest exponent. Yeah. What is the highest exponent here? I see.
So it will be negative 5x to the 4th plus.
You see, it's this one here.
Plus 4x to the 4th, and then plus 4.
This one here, and then plus this one here. You see, I have 3 to group. Negative 5x to the 4th. 4x to the 4th, 4x to the 4th. When I put the numbers together, how much I get?
8.
8, which is minus 5, which is 3, right? Yes. Because I have negative 5, the first one. I have 4, the second one. I have 4, the second one, right? Negative 5 plus 4 is 3, right? I get 3x to the 4th. Okay, now I move to the next exponent that I see here. What is the next exponent I see? The big one. The biggest.
It would be negative 4x squared plus
negative 4x squared
plus 6x
plus 7x squared plus 6x squared. Everybody agree with that?
Yes.
I just put together the numbers up front. Is negative 4 plus 7, which is positive 3, and positive 3 plus 6 is positive 9.
Yeah.
9x squared.
X squared. Yep.
And then the next power I take care of is the power 1, right?
Yep.
Is I have 6x, negative 2x.
It would be 4x.
Yeah, is it for 4x? Thank you very much. And then the numbers now.
Plus
you see, these two together, they just cancel out. 8 minus 8 is 0, right?
Yeah.
I have covered everything, so I'm done, right?
Yeah.
So that is how we add or we subtract exponent. Now how we multiply exponent, right?
Yeah.
First of all, you have to remember multiplication now. First of all, when we multiply variables, it tells you when you do x squared times x to the 4th, what you do to the exponent.
Multiply.
Add.
Oh, you add them. That's right.
Add the exponent, right? It will be x to the 6th, okay? When you do x times x, how much is that?
1.
X.
There's no good answer yet.
X to the 1st.
It's simpler, but we do more mistake with this one than the other one. This one is simpler than the just one.
Just X.
X to what power?
First, 1. No, 0, 0.
2.
No, x to the second power, x to the 2. Because what are the power? What are the invisible powers that we don't need to write?
1
and 1, right? You see 1 and 1. What do you see in between? I see a multiplication sign, right?
Right.
Every time it is a multiplication sign, you have to add the exponent, right?
Okay.
Not to conflate with that. Not to conflate with what we just been doing, which is x plus x. How much is x plus x?
X.
X to the x squared.
The plus does not change the power, remember? The plus does not change the power, okay? So the plus is you just add the numbers in front, the numbers in front of each one of them. If you do one, it's going to be 2x, right?
Oh,
do not conflate x plus x with x times x. X times x, actually the exponent will change, right? Because it is a multiplication. Is x to the 1 power times x to the 1 power, and 1 plus 1 is 2, right? It's going to be x squared. You see, it's going to be x squared, which is 1 plus 1, right? Okay. So
I have a question.
Yeah, go ahead.
So how you wrote your last answer, I had 4x plus 3x to the 4th power plus 9x squared. I had my 4 in front.
Yeah, you're absolutely absolutely right.
Oh, okay. I saw yours was backwards. I said, oh no, I'd have messed up. So
no, the order again, the order is not here. The order of the answer is not important, okay. Right? But to the aesthetic point of view, right, it's always nicer to have a certain order, right?
Right.
But that is just for, I mean, for aesthetics, you know. I mean, some computers, they could ask you to, they could ask you to order them. Okay, some computers could ask you that. All right. So right here, you see everybody. You see the difference between x plus x and x times x. Do you see the difference? Every time it is a multiplication, the power will change for sure, right? When you do this, when you do x to the third times x, how much is going to be? What power are you going to have?
X over 4.
X to the 4th, right?
All right.
Okay. So this here, and when we multiply now, when you do this, when you do 5x squared multiplied by 4x to the 7th, right? For instance. When you multiply them, what you have to do, you just gonna go, don't overdo it. When I say don't overdo it, don't think here of any distribution. You just go ahead, everything here is a multiplication. There's no distribution here. Just go ahead and multiply 5 times 4 is what?
20.
20. And then x squared times x to the 7 is x to what power?
9.
X to the 9, right?
Oh, you're adding, okay.
You add, okay? So this is what you're going to practice in a more complete setting, right? But this is what you're going to practice actually. So this is the multiplication. This is what you're going to practice. So if you go ahead and, you know, we look at this is like 3.5, by the way.
What happened?
Got cut off again.
I got shut off.
I hear you now.
Yeah, I'm gonna call you back after school.
Okay. So right here. So okay. So we're gonna say multiplying polynomials. This is 3.5, right? Multiplying polynomials. So we're gonna try to multiply the polynomials. So for instance, we say that is 3.5, multiplying polynomials. So for instance, let's give an example right here first. So for instance, we say, what is 4x cubed? I mean, let me just give an example right here. You see, we have 1 terms distributed to a parentheses. This is our first example. 1 term that we distribute to a single parentheses, okay? All of you know the principle of distribution, right? See, if you have something like that, what you're going to do? What you're going to do to the term which is up front? What you're going to do to it? You're going to distribute it to?
Multiply. Oh, to everything.
Yeah.
to everyone. Yeah.
How we call that? We call that distribution. This happens every time we put together multiplications and addition subtraction. When we do that in this way, the 4x cubed in front has to be distributed to everybody inside the parentheses, right? Everybody. You see? And since now we saw quickly this type of example is going to help us figure out what's going to be each term multiplied by each term. Now, if you want to, you can go ahead and do it mentally, or if you want to, if somebody wants to write the steps, you can go ahead and do this. What's going to be the first distribution? This times this, right?
4
It's going to be 4x cubed times what? 5x squared. You see what I'm saying here? You don't have to pass by this step. You don't have to, okay? But this is the first example. We're going to write it down. Maybe some of you will need to see it, right? Okay. What is the second distribution here?
Negative
4x times 2x.
Minus.
It's going to be plus 4x, or minus, I'm sorry, minus 4x cubed, parentheses 2x, right? Okay. What's going to be the last distribution? Plus
5
times 4x cubed, right? 4x cubed times 5, right? You see, I don't think all of you need to write this step right here. I don't think so. I have some students in the past. I have some students who need to see this step to proceed. I have some students who say, okay, 4x cubed times 5x squared is just 20x to the 5th, you see?
Yeah.
You know, some of you don't need to write this step right here, but if you want to write it, you are welcome to write it, okay? So now we go ahead and write, what is 4x? Exactly as we did here, with this one right here, we're going to multiply the numbers together and the variables together. It's going to be 4 times 5 is how much?
20.
20. X to what power?
3.
5.
X to the 5th, right? Because the 5 comes from 3 plus
2.
3 plus 2 minus what?
8.
8. X to the 4th. Thank you. Plus what?
20 x to the 3rd.
20 x to the 3rd, right?
It wasn't a lot of steps for that. I had a lot of steps, but
No, this is, you know, it can go like 2 steps. I think mostly 2 steps. But this one, because we are in the next, we didn't have like more steps because we have nothing to prove. Okay.
Okay.
Our last answer, all the exponents are different, so we have nothing to group. But in some of the examples, actually, we can have more steps, which means when we have, for instance, a parenthesis multiplied by another parenthesis. For instance, this one right here. A parenthesis multiplied by another parenthesis like this. You see this one here, we'll have, okay, now if you do the distribution, before we even do it, at first, when you distribute normally, before any simplification is the first step, how many terms you're gonna have? How many terms?
3.
How many terms you're gonna have before any grouping? The first step when you distribute, how many terms you're gonna have?
2.
You're gonna have more than 2, more than 3, more than 4. The first, you remember the first parenthesis, everybody in the first parenthesis will be multiplied by everybody in the second parenthesis, right? How many terms in the first parenthesis? We have 1, 2, right?
Yeah.
How many terms in the second parenthesis? We have 3 terms. When you multiply everybody by everybody, you'll have 6 terms. That's going to be your first step. Your first step before any grouping is going to be 6 terms, right? Okay, now we go ahead and we distribute one by one. 2x times 4x squared, how much is that? Do we need to write this step? Do we need to write 2x times 4x squared, or do we just go ahead and proceed?
Just go ahead and proceed.
Yeah, I think it's better. So how much is going to be 2x times 4x squared then?
8.
8x to the third.
8x to the what power?
3.
Third.
3.
Third. Thank you, because this is 1 and this is 2.
Mm-hmm.
Okay, and now this one right here is the next one. What's it gonna be?
14.
Negative 14.
Negative 14. Yep. X to what power?
2. The second.
X to the second, because we have 1, 1, right? 1 plus 1 is 2.
Uh-huh.
And the last one now is how much?
6x.
6x. Thank you. Is 2x times 3, which is just 6x. You see, I am done with the first one. Now I have plenty of colors, so I change my colors and then I go to the next one right here.
Okay.
So just
How
to
much
make,
is that?
I just have a quick question.
Negative 20.
Go ahead.
On the 6x, you don't put no power there, right?
But it's understood to be 1.
Oh, okay, okay,
We don't need to put 1, but it is understood to be 1 there.
okay.
Okay, now I go with my green parentheses now, my green stuff. It's going to be minus my negative 20 what?
X to the second.
Okay, since I know, and this is what's very important, since I know I will have to group like terms, I try to be organized at first. You see the negative 20x to the second, I will put it underneath what? What term? Underneath, you see, I put it right here. That is very organized, you see? Because in my next step, I just will go ahead and add up each column, right?
Okay.
That just is for organization's sake. I try to be organized to avoid mistakes, right? That's it. That's it. What is the next one here?
Positive
Plus 35.
Plus 35 what?
X.
X. Thank you. You see, I put it underneath the 6x because I know in my next step I will have to go, I will have to put them together. And what is the last one?
Negative 15.
So it has no vis-a-vis, so I just put it right here. You see, my next step is going to be what? I just go ahead and I add the columns. 8x cubed is by itself.
Oh, I see. Okay.
Negative 14 x squared minus 20 x. How many x squares we have?
2.
This one right here. When you put them together, these two right here. When you put them together, it's going to be what? Negative what?
34.
Negative 34x to the second power. And these two together, how much we get?
41.
41x and then minus 15.
Okay.
Okay.
Yep.
Again, this is a distribution, right? It's just a regular distribution. You know, the bigger parentheses we get, the more steps, I mean, the more distribution we have to do. But the principle is the same principle. It's actually exactly the same principle. All right. So let me try to see if I have another some that are similar. Okay, so right here, for instance, the first one, 4x plus 7y. Okay, so I mean, I don't get distracted because I have xy, okay? If I have xy, I have xy, you know. But we do the same thing, exactly.
Okay.
All right, so here, this one, it will be even shorter than the one we just did because of, we have two parentheses, we have two terms times two terms. But here, you know, the only reason we do this one because we have XY, right? So what is the first one? When you do this, how much you get?
12.
12.
X what?
X.
X squared.
X squared, right? Thank you. 12x squared. The second one, how much you get?
8.
Positive 8 or negative 8?
XY.
Negative 8, X, XY. You see, there's nothing more you can do with XY, except XY. You cannot say X squared, you cannot say Y squared, it's just XY, right? And then the next one will be what?
21yx.
21yx. And is xy any different from yx?
No.
Is it exactly the same thing? You should have plus 21yx, which is xy also. And the last one will be what?
Matter.
Huh?
So it doesn't matter.
No, it doesn't matter because look, if you replace it with numbers, what is 6 times 3? 18. What is 3 times 6? Is also 18.
Okay.
It's used, the order doesn't matter, right? XY, YX is the same thing, right? So now the very last one will be negative 14 what?
Y to the second power.
Y to the second power, thank you. Now I have do I have any like terms here?
Yeah, the XY.
The XY are exactly like terms. I see exactly the same variables. I see exactly the same powers. So they are like terms, so I can group them. It's going to be 12x squared
plus
minus 8x, minus what? How many xy's? Or plus what? Plus 13xy. And then minus 14y squared. All right? So these are right here. So now what I'm going to do here, I'm going to give you some to do, right, by yourself. All right. Okay, so you have 2 of them to do. Just try to go ahead,
Going on in the background, can you please make it? Thank you. Appreciate it.
Okay, so are you done with the first one?
Yes.
All right, so can somebody walk us on through the steps, please? What you did? So the first one is, go ahead. This time this, how much we get?
I got 6R.
6R to the second. That's what I have.
R to what power?
3.
Second.
3.
Where did 3 come from? This one here plus this 2, R to the third, right?
Yeah, got that.
Yeah.
That was my next step. That wasn't
Yes. Okay, 6R to the third, exactly. And then the next one, look at the next one right here. What's going to happen here?
It would be
negative R to the second.
Negative R to the second, thank you. Right? Again, 1 and 1 is 2. And the last one will be what? Plus what?
5R. 5R.
Plus 5R. Okay, thank you. And then the next step right here will be this times this, which is?
Negative 42R.
Negative 42R to what power?
Second.
R to the second, that is right. You see, I put it right underneath the R squared just to be organized, anticipating for my next step, right?
Right.
Okay, and then this one, negative 7 times negative R will be how much?
Plus 5R.
Plus 7R.
7R, right? 7R. Okay. And lastly, negative 7 times 5 is minus 35. And then I go ahead and do my equal here is going to be 6R cubed by itself minus how many R squares? 40 what?
43.
Minus 43R squared, right? Plus how many R's?
12R.
12R minus
35.
35. Exactly.
Got it.
That's good. So,
finally.
I didn't finish the second one yet.
okay, so the second one is longer, a little bit longer, because we anticipate to have 9 terms at the beginning, 9, right? Which is a little bit too much. So this is, the first one is 48 what?
N to the 4th.
N to the 4th, right?
Minus 40N cubed.
Minus 40N to the 3rd, yep.
Plus 48N squared.
Plus 48N squared. So we are done with the first one. And then the second one, you know, we're gonna just be organized, right? Again, you know, why in math we try to be organized this way? To avoid mistakes, right? Yeah. That's it. Yeah. So this is 24 what?
N to the 3rd.
24N to the 3rd, right?
Minus 20N to the 2nd.
Minus 20N to the 2nd, and then
24N.
24N. You see?
Yeah.
Not done yet, right? So we have one last one to do. And then what? Plus
36 N to the 2nd.
N to the 2nd, right?
Minus 30N plus 36.
Minus 30N and then plus 36, exactly. You see, now we have 3 rows to group. When you group them together like that, we get 48N to the 4th minus 16N cubed, right?
Right.
Now we just avoid mistakes now. We just avoid mistakes. 28 plus 36 is 64.
N to the 2nd.
N to the 2nd minus 6N and then plus 36, right? So we just avoid mistakes. Once we understand the process, the next step is just to avoid mistakes. Because mistakes are, you know, unfortunately, when we do like, you know, algebra stuff, mistakes are, you know, penalized in a way. When you do mistake, your answer becomes wrong. And when the answer is wrong, we cannot just say, oh no, it's almost the same. We cannot say that, right? The only way to say that in math is this is for higher math. In the higher math, we don't focus no more on the numbers. We focus on the theory, right? You see, when you focus on the theory, the numbers, it's like the numbers don't matter. When you say, 2 plus 3 equal to 7, it doesn't change. It will not change your proof. For instance, when you reach a level of math where you have to prove something, but that's like, graduate level, right? Then the mistakes, like the numerical mistakes, they don't matter almost. Because they will not change, they almost will not change your reasoning. They don't change your reasoning. But when you do algebra, the mistakes do matter, okay? When you do a mistake, this messed up the grade, right? Somebody should have like 10 points, they end up having 4 points because they did a mistake somewhere, see? Especially when you do a mistake at the beginning, right? So that's why, we try to avoid mistakes just to maximize what we can get from this stuff. If we understand the process, after we understood the process, now we have to watch out the mistakes. So we have a test. Okay, and the last stuff we're gonna start it, right? I know is what we call special products. And this might be 3.5, I think, or 3.6 maybe. Special products is some products that are particular. Yeah, it's 3.6. For instance, so everybody, can you go ahead and do this? Do A plus B, parentheses, A minus B. I let you like a couple of minutes to do that. What you're gonna get? You distribute and you try to simplify. Distribute, simplify.
A minus B.
Yes, A plus B, parentheses, A minus B.
A to the second minus B to the second.
A to the second minus?
B to the second.
Yep, I know, looks like you got the right answer. Okay, so because here, look, A times A is what? A to the second, right?
Second, yes.
Minus A times B, which is minus AB, right? And then plus
BA.
BA, which is what we said before. It is the same as AB, right? BA and plus AB, they're the same. And then minus B to the second. Now, what happened to the one in the middle?
They cancel out.
They cancel out. So we get A squared minus B squared. What they're saying now, every time you see something like that, you can take this shortcut. So A plus B times A minus B is equal to A squared minus B squared, or A minus B. It doesn't matter which parentheses come up first. It does not matter which parentheses come first. A minus B times A is going to be also A squared minus B squared. This tells me if I remember this formula, it's going to allow me to do the shortcut, right? For instance, you want to do x plus 5 parentheses x minus 5, right? You can go ahead and do actually the FOIL, right? You distribute, or you can go ahead and say, I do recognize this formula, right? Don't I? The x plus 5 matches a plus b. The x minus 5 matches a minus b, right? So instead of me doing all this work, I can go ahead and say this is just a squared minus b squared. Who plays the role of a? Who plays the role of a here?
X.
X. Who plays the role of b?
Oh, 5.
I can go ahead and say this is a squared, which is x squared minus 5 squared, right? That's it. I'm done. It's x squared minus 2 and 5. What I saved myself? I saved myself the distribution step, right?
Yes.
You see, everybody see that? But I have to make sure what I see in front of me does match exactly a plus b, a minus b. I have to see the same stuff in both parentheses, and I have to do plus. I have to see plus somewhere and minus somewhere, right? Okay, so if you have this right here, right? Without distribution, everybody, we try to do this. Try to do this without distribution. Just try to apply the formula, right?
Can you move it up just a little bit?
Yeah, okay, so like that. Okay. So the three of them, do they match the formula a plus b, a minus b? Do they match the formula, the three of them?
Yes.
They do, right? Okay, so when they do match, you have just to recognize who plays the role of A and who plays the role of B, okay? Once you recognize that, you just go ahead and square both of them and put minus in between, right? So for instance here, The first one here, what you gonna say? It's gonna be what?
6. Oh,
the first one here.
X squared.
Minus
81.
Minus 81. Thank you very much. That's it.
Yeah.
X squared minus 81. You see, what it did save me. It did save me all the distribution step, you know, which is like sometimes annoying, okay? Right? So for instance, the second one right here, the second one, I recognize this is a perfect square. Now for the second one, I have to pay attention now because the 4x is composite, right? I have 4 and x. So to avoid a mistake, I'm gonna say, actually this does match a plus b, a minus b, it does match. So I'm gonna say this is 4x squared, I'm gonna write this way, minus 3 squared, right? Now when you square 4x, when you square 4x all squared, what you get?
16x.
Don't forget to square the 4 also, right? It's 16x squared minus 9.
Yeah, that's dope, my answer.
All right. The last one here, same thing. You have to square 6x parentheses squared minus 8y parentheses squared, right? It's going to be 36x squared minus 64y squared. Again, this slide here saves me all the distribution steps, you know, where I can do mistakes, etc., etc. Don't forget this formula. A plus b times a minus b is a squared. Don't forget about it because you're going to see it if you have some other maths to do, right? All right, so we're going to stop here for today. I just talk about the quiz. I did set up the quiz, right? So let me go to my my Brightspace. The quiz will open right after the class, and you will have, you know, until I think Thursday noon. But let's make sure. Let's make sure about that, right? Okay, so if I share my screen, so you're gonna see my right here. Hold on. Yeah, Brightspace. When you go to Brightspace right here, you go to your class right here. So you're gonna see that right here. You see when you go to quizzes, you go to quizzes first, and you're gonna see quiz number 2 that is available on October the 19th, which is today at 8:30. Right? Until what? October 21st at 12 o'clock. Okay? You click on the quiz only when you are ready to go. Only when you are ready to do the quiz, right? For those people who have accommodations, I did, you know, give you more time, right? According to your accommodation. So right here, you click on it, right? Only you start the quiz only when you are ready, when you have 35 minutes, 40 minutes for yourself, right? Okay? Because when you start the quiz, it is timed. If you start at 8:30, you cannot submit your answer at 10 o'clock, okay? You cannot. You just like quiz number 1, okay? You click on it, you're gonna see a PDF file, right? You won't be able to see it until 8:30. You're gonna see a PDF file, you click on the PDF file, you're gonna see the questions, right? I think like 4 or 5 questions, not a lot, okay? And you have like 35 minutes to do it, and then about 10 minutes to upload your answer. Now, where do you upload your answer? It's not in the quiz tab. You go to the assignment tab, exactly, and you will see submit your quiz to here, right here. You see, you're gonna see that when you click on that, you're gonna see the, you know, add a file, just like quiz number 1, add a file, and then you're gonna go ahead and add the file. Please, you know, I would appreciate if you know how to get a PDF file. This is better for me. Some people send me pictures, you know, I take it, but it takes me more and more time to grade because I have to transform all the pictures into PDF files. And that is one of the reasons why, you know, I have to spend like several days because imagine I have 6 classes, like, you know, student sending me like, you know, for the test, for instance, the quiz, I don't expect a lot of pictures, but for the test, I can get up, somebody can send me like 10 pictures, you see. It takes me time to transform all these pictures to PDF so I can grade. So if you can do it, if you practice before the quiz, you know, you have some free apps, you know, Adobe app, scannable app, where you can practice scanning a paper, you know, something and making it a PDF file. You know, they are very simple to utilize, very, very simple. You have just to practice it before the quiz comes, right? It will help me actually, it will help me. Now, if you cannot do otherwise, you can go ahead and send me the picture, right? Or submit the picture.
So I have a question.
Yes.
One more question, because it's so we print it out and we don't submit it until Thursday. But you're saying
no. When you open it, you don't open it until you are ready to do it and to submit it.
Oh, okay. Okay.
It is open until Thursday noon.
Gotcha. Okay.
But when I say Thursday noon is for the submission.
Mm-hmm.
You see, you don't wait until Thursday 50. I mean 11:50 and start. Like unfortunately, some people do that. You see, which I don't understand. You know, if you actually you can get 0 out of something, you don't take those risks. You know, why wait until the very last minutes? You know.
You're right.
You know, this is like, you know, unnecessary risk, you know, stuff like that. So, but you don't rush to study right now because, you know, unless it's almost 9 o'clock, you wait until you are ready, right? You have time for yourself. It's a regular quiz, just like quiz number 1. Try to do good on it because each quiz counts for 5%, which is a lot, right? If you get 100% of the quiz, it does help. You know, it does help. So try to do that, prepare. It's going to be, yes, the quiz will be, you will have, you know, probably, hold on, let me see. I have to stop sharing my screen for that. Let me see what is on the, you know, on the quiz number 2. On the quiz number 2, you have one word problem where, you know, a purse that has some coins, etc., etc. You remember that those were problems? You have one of them. And then the next questions are about exponents, right? You know, exactly the same stuff we did, exponent to, you know, we have like one word problem about systems, right? You have to set up the equation, the system, and then solve it. Exponent problem, and then a scientific notation problem. That's it. You have 5 problems. You can do like, you have 35 minutes. Actually, it can take you like, you know, no more than, I don't know, than 20 minutes, something like that.
Pretty hard, 5 questions. I'm like 5 questions, 35 minutes.
They are just regular, they're just regular problem, you know. You say, for instance, the word problem where you have, you know, a purse contains quarters and dimes, you know, etc., etc. You know, those word problems we did in classroom, same one of them, right? Just one of them. And then the exponent problems, these problems, if you know them, it does not take you like 30 seconds if you know them. Now, if you don't know, it's different. Because they are not like, you know, they are usually like 1-2 steps problem, okay?
Okay.
And what I was saying is this. I was saying here, for instance, you have some exponent problem right here, for instance. I give an example and then before we go, and then we're gonna stop the class here today. Okay, so if you have this, and this is very, yeah, let me show you the what I was thinking, right? If you have this stuff right here, if you have, you know, 5x cubed y to the 7th times 5 to the 4th, x to the 8, y squared cubed. Okay? If you do this right here, if you do this, 5 to the 13th, x to the 27th, y to the 13th, right? If you do this, I'm going to be suspicious. Okay. You have to write the steps, you see?
Yes.
You have to write the steps. So whatever you thought to get this step, you have to write it down, okay? Please. Because some people, because now it is a take-home test, some people go ahead and give you the very last answer, you know. Say, okay, did you get it from somewhere? This is a question that comes to my mind, you see? So now what are the steps I mean by that? Not a lot. It's just, you know, you instead of writing this directly, what you say 5x cubed y to the 7th times, you see now you have to distribute this power here, right? It's going to be 5 to the 12, right? X to the what power? 24th. And y to what power? Y to the 6, right?
Mm-hmm.
And now you go ahead, you say 5 to the, these two is going to be 5 to the 13th, we add the exponent. This 2 is x to the 27th, we add the exponent. And this 2 is y to the 8, y to the 13th, right? You see, I need to see at least one step, you know, to say, okay, you work it out, okay?
Okay, can you go up a little bit?
Is this?
More to the top, a little bit more, because I can, there you go, perfect.
Okay, you see, I just need to see one step. And in the test, on the quiz, you're going to be you're going to see example like that, you know. And these are examples we practice in classroom, you know, not harder, not easier, just something like that. Okay.
So where did you get the 13 from? You got 5 and 13. Where did the 13 come from?
This one right here.
Yeah.
Yeah, I mean, you see, I was making the point. Don't write the final answer. Do not write the final answer directly. You have to go through the steps, right? Mm-hmm. And when you look at this step right here now, when you break it down, this 3 times 2 is 6, right? It's going to be y to the 6 right here. And we had y to the 7. What is y to the 7 times y to the 6? Y to the?
Y to the 13, right.
Yes. And what is 5 to the 12 times 5 to the 1 power? 5 to the 13th, right?
Power. Okay, all right. Yeah. That's where the 13 came from.
Okay.
All right.
All right, everybody. Good luck to you, and see you next week.
See you. Thank you.
See you. Thank you.
Thank you. Bye.
All right.
Thank you.